Figured I'd give you guys a little bit of a rundown since it sounds like you all are kind of interested in this process. So I've been working for probably the last 4 or 5 hours just cleaning the pistons, because we've used these pistons for the last 3 years. And every time we take the engine apart, we like to do some inspection to check the pin bosses to make sure the ring grooves are still good and true. And obviously you want to check your rings. This go around, I did find that my second ring down had lost a little bit of tension. So I did a custom ring package on this combo whenever I first built it 3 or 4 years ago. And we sent the pistons back off to Diamond and had them do a set of tool steel top rings. So it's got a 16th inch thick tool steel M2 total steel ring on the top. That's basically the same ring that, from my understanding, the top fuel dragsters and all those guys use. It's the only thing that can handle extreme pressure and heat. So we don't run water in this motor either. So that was another reason to try to put a little bit better ring on the top. Now, there wasn't enough room to add a 16th on the second ring land, so we stayed with the 043 thickness, which is a ductile iron that's part of the AP ring set that Total Steel sells. So anyway, I'll turn this around here. Pardon my mess here, but it's chaos whenever you're building motors and everything else. So these right here are the rings that I took out. Whenever I got the new rings in, you could overlay the old ring on the new ring, and you could see that this one, it collapsed some. So the new ring was actually bigger around, meaning this little gap right here was wider. It's like it was swelled out like this. That's a good way to tell if your ring has lost tension. The top ring was still really stiff. Let's check our piston to do the rings. But anyway, we ended up replacing 2 pistons in the motor. Whenever I ordered these pistons, I basically ordered 10 of them. And the biggest common issue with these LS motors, really, once you start getting up close to that 3,000 horsepower, is this right here. This isn't actually the wrist pin that goes in here, but as far as the diameter goes, this is a 927 wrist pin, which is your standard small block. And it's kind of retarded because this is actually smaller than a stock LS1 wrist pin. A stock LS1 wrist pin is like a 934 or 944. I'm just going off memory here. I know there's a 4 in there, but it's about 10 or 15 thousandths bigger in diameter. And the ZR1, and don't quote me on this, but it's something like close to a big block, like a 980 something, or a big block is 990. So a lot of guys will run a 990 wrist pin, which is almost an inch in diameter. Anyway, the reason we replaced these pistons, there's nothing wrong with the piston itself. You know, it's got a little bit of skirt wear, which I would expect on, you know, something that's making 2,700 horsepower. And these pistons have about 200 passes on them at that power on top of that. So yeah, it gets a little bit of gouging on the cylinder walls, you know, putting that much power through it. But the really major concern that I had, the wear right there, there's like a groove that you can feel with your fingernail if you scrape across it. So what that's done, that's where the end of the wrist pin is in there. What'll end up happening under a lot of passes, that little pad right there on each side is what's having to harness every bit of that horsepower to apply it through the wrist pin into the rod. these had a little bit of a groove in them that I didn't like. I mean, they were still within spec. You know, you put the wrist pin in and put the rod on, and, you know, it didn't have any abnormal rock or play or anything. But if I can feel that pin boss bore with my finger, then I've got 2 new pistons, you know, spare. That's a good thing also about really inspecting your parts real close when you tear into these things, and pay attention. Look at the bearing wear. You know, these right here are the rods that I took out. And so you can look at this top shell, and, you know, naturally the power is pushing it down. You're not really going to have much load on this part. This is your coast side, but all your power and compression is going to be on this bearing here. So you can look at, you know, the bearing, and as you can see, these right here probably have, I don't know, these rods have been in since the dart block, and they were in the LSX block for a little while too. So yeah, I mean, they still have the coating on them, so it hasn't even wiped the coating off on that particular rod. But you can look at each one of those rods and kind of determine, you know, what each cylinder is doing. And I always do this whenever I tear a motor apart, because it's the best indicator. If your tune-up is bad, you can definitely tell if you're getting detonation or not. But back to it, we've got the short block assembled, at least the crank rods and pistons anyway. Got everything cleaned up real good. I spent most of the day actually trying to get these 2 orifices plugged off, because the last time I ran this LSX block, we were running a factory style oil pump, and as you can see, I've got that blocked off now too. Now we run a belt driven external pump, and I had to block all these galleys off because right here is the actual oil feed now. So you'll have a pump up here. Actually, it's on this side, I'm pretty sure. That's belt driven off the harmonic balancer, and it pumps oil through a external oil filter, and then out of the oil filter straight into the motor here. Still running factory electro wheel, 58 tooth. Yeah, it's a little bit of a daunting process getting all the parts clean, and probably have some more time tomorrow just cleaning the windage tray and cleaning up the oil pump and all the other stuff. So I've got the cylinder heads tore apart here. We're basically changing valve springs. These valve springs have also got about 200 runs on them, which some say I'm crazy for running that long. This thing has a 800 lift roughly. I think it's like 790 lift camshaft that's in it. We aren't easy on it. I mean, this thing sees 86, 8700 almost every pass. I've already inspected this head. I've just got to clean it, check all the valve tips, make sure everything's good, check all the locks, lock grooves, check all the titanium retainers. At this level is a wear item. It's usually good to change those if you see any kind of wear and whatnot. On the back side, we'll look at all the valve job on each one of the cylinders to make sure, you know, everything is still kosher and not ate a groove or anything. This cylinder head at the exhaust side had maybe a little bit of a groove in it, but honestly, it being the exhaust side, I'm going to send it until I swap to our new cylinder heads. John at CID is hooking us up with a set of hydraulic roller CID heads. This is a solid roller. The very first iteration of his LS7 head, they were actually still using Greg Good for the CNC programs and stuff. So this head here is actually ported by Greg Good. It's got a little bit smaller valve and a smaller port on it, which here recently I think might be actually holding us up a little bit. Is north of about 42 to 43 pounds of boost. The car shows a bigger number on the dyno, but at the track, if I try to run 60 pounds of boost in it out the back, it doesn't pick up anything. There's a lot of contributing factors there. You know, the cylinder head could be part of it. And also me finding those piston rings that were a little bit weak. I think we may have been losing some cylinder pressure to the crankcase. We have had some crankcase pressure, I wouldn't say issues because it was controlled. It didn't really get over 5 or 10 PSI, but obviously the lower the better. That motor had seen basically 5 to 8 PSI almost every pass by the end of the pass. But this is the prototype BTR intake that we ran at the end of the season last year. This is actually modified by 417 Motorsports. So what we did was we took this BTR plenum and we cut the roof off of it. We cut the snout off of it, and I sent all that down there to Blake. He naturally has these billet flanges here where he makes his Holley style intake manifolds, and I had him weld a plate on the front here to fill in that gap, and he welded a billet plate to the top perimeter here. So this is basically a BTR lower modified to cut the roof and the snout off, and it's got a Holley flange now. And then obviously we run his 417 sheet metal lid on it. And maybe later in the year, if we get some time to stick the thing back on the dyno and test intakes, we'll test that other intake plenum. I've got another intake in the works too. Since John is helping us out on cylinder heads, he wanted us to run his intake manifold too. So we've got one of the 5.0 cross-section single plane intakes. It's actually in that box that the other intake's sitting on right now. I really need a 16 injector model, so I'm actually going to send that one back because it's just an 8 injector model. Get it swapped out with a 16 injector deal. I've also got to source a billet elbow so that I can get the throttle body, and I'll have to probably fabricate another charge pipe and all that. Yeah, that's a little update on what's going on at the old ShorTuning place. So hopefully you guys kind of updated. I'll try to make another video tomorrow kind of going through, you know, cleaning the heads and assembling the heads, and then maybe try to set up a tripod to, you know, set in the camshaft, and you know, before we put the cylinder heads on, we'll show you how to do a dial indicator on the lifter and degree the camshaft in and all that fun stuff. That way we know exactly where our cam timing events and stuff are. So we have a hex adjust timing set on that motor to get all that dialed in. So I guess that's it for now. I'll try to get another video out sometime this weekend with more motor shenanigans, and hopefully maybe we'll have this thing fired up this weekend and make another video showing you all that too. So that's it for now. See y'all later.